Chapter 9, Section 2, solve equations using square roots. Remember back to when we did square roots last year, I think, maybe 6th grade, I can't remember. So you have a perfect square, you take a square root, its answer is plus or negative 4, because plus or negative 2, because 2 squared is 4, negative 2 squared is also 4. And remember from earlier this year, when you don't have a perfect square, let's see, like 32, you do your tree, and see, 4 times 2. Every time you see it appear twice, you put it once outside. 2 times 2, square root of 2, 4, square root of 2. Technically, we did this wrong because we didn't do any of the negatives, but it's a positive or a negative. All right, moving on. If you have x squared equals any number, you can solve that by taking the root of each side, which we did over the summer when you did Pythagorean theorem. When d is greater than 0, it has 2 real solutions. So as you know from graphing, that means it would look something like this with 2 real solutions if d is greater than 0, so if d is positive. If d is equal to 0, it has 1 solution, so the parabola sits on the x-axis when d is equal to 0. If d is less than 0 or a negative, it has no real solution. It only have imaginary solutions. So that means you take a square root of a negative number. You cannot take a square root of a negative number. 2 positive numbers or 2 negative numbers do not multiply to be a negative number. So you take the square root of what's there, and then this throws an I on it. So that would be 2i or a negative 2i. Those are imaginary numbers. But anyway, that just shows that it doesn't cross the x-axis, so there is no solution, no real solution. All right, so solve this using square roots. So we have to get this by itself. 3x squared, add 27 to both sides. Make sure you do that work so you don't make a mistake and lose a sign. Now we have to divide, that's not a negative 3. Divide both sides by 3, x squared equals 9, square root, x equals plus or negative 3. Okay, now you do this one. Hit pause and do this one. Did you get no real solution? If you got no real solution, you can take a picture of your work and move on. If you did not get no real solution, let's see what went wrong. So I'm going to subtract 11 from both sides. Negative 5x squared equals 5. Divide by negative 5. X squared equals negative 1. Okay, right here I see x squared is equal to a number that's less than 0. So my answer is no real solution. If you want to know how to solve it, take the square root of both sides. X is equal to I times the square root of 1. Square root of 1 is 1, so x is equal to plus or negative 1i. That would be your imaginary number solution, which this isn't asking for, but it's something you're supposed to be exposed to. All right, hit pause and see if you can do this one on your own. If you got x equals 6 and x equals negative 4, take a picture of all your work and insert it. If you did not, let's see where you went wrong. All right, so by looking at this, we know right now that it is not, its vertex is not at 0, 0. So, and it's greater than 0. So we're going to have 2 real solutions, but we need to know what they are. So we need to get just this by itself. This squared needs to go first. So we're going to take square root of both sides first. So that gets us x minus 1 equals positive 5. And x minus 1 equals negative 5. And I like to put it in 2 separate ones because I've got 2 separate numbers. Add 1 to both sides, x equals 6. Add 1 to both sides, x equals negative 4. So hopefully that's what I said in the beginning. So your answers, your solutions are x equals 6 and x equals negative 4. So your parabola would look something like x equals 6, x equals really wide. Okay, real world problem. Hit pause, see if you can answer it. Did you get the width is approximately 5.5 feet and the length is approximately 16.4 feet? If you got 16.5 feet, that's fine, but 16.4 is better. When you did all the work and before you rounded, that number should still be in your calculator. So take that number that's in your calculator with all those digits to the right of the decimal and multiply that by 3, and that gets you a better answer because it's rounded further out. So the further digit to the right that it's rounded, the more accurate it is. So 16.4 feet is an approximation, but it's a better approximation because it's more digits in what you multiplied by 3. So if that's what you got, you may move on. If that's not what you got, let's see what's going on. Okay, so read carefully. It is a tank with length, width, and height. So it is a rectangular prism. Volume of a rectangular prism is length times width times height. So I need to know what each of these, I need to know what 3 of the 4 are. So they tell me the volume. They tell me its height. They tell me the length in relationship to the width. So that means width is W because that's the only thing I know about it. And the length is 3W. So now I'm going to plug in my numbers into my equation and okay, length is 3W, width is W, height is 3. Now I'm going to simplify the right-hand side, 9W squared. I'm going to divide both sides by 9. That is 30 equals W squared. Now I take the square root of both sides to get the width by itself. Okay, so that would be plus or negative 30, but it's a width. It can't be negative. So I'm just going to do the positive square root of 30. 30 is 3 times 10. Neither one of those is a perfect square. So I'm going to use my calculator. I'm going to do square root of 30, which is 5.4772255750516661. But the directions say to round to the nearest tenth. So that's my tenths place. So that is approximately 5 5/10 feet. This number is still in my calculator, so I'm going to find my length, I'm going to multiply that by 3. And that gets me 16.4316, blah, blah, blah. I'm rounding to here, so that stays the same. So we know the length as 16.4 feet is more accurate than 16.5 feet. So we try to be more accurate as possible. And of course I should write a sentence. The tank has a width of about 5.5 feet and length of about, because we rounded, and you don't be this messy when you write over it like that. And that's the end of this. So now you know how to solve quadratics by factoring and then setting them equal to 0, by graphing, and now by taking the square root, which we know we can only do when we have an x squared or variable squared, but not, not this. You can't have that x. It can only be